Here we go. Let's get after it. Here's a short little video on a add and subtract fractions refresh here. So here we go. So remember that when we add and subtract fractions, we need to have a common denominator. This number needs to be the same. Why do we need that? Is because if you remember that every fraction is based out of the number 1, we could imagine that every fraction is one ice cube tray that is exactly the same size. But what we have in this scenario is one of them is broken into 7, the other one is broken into 14. Now those ones are the same size. So in this case, you could tell that these ice cubes are way bigger than these ones. So we can't just add them together. We need the same size ice cubes. We need a common denominator. So how do we do that? We do that using equivalence. So if you look at your two numbers, remember you're guaranteed to get one by multiplying them by each other. That's going to happen because 14 times 7 is the same as 14 times 7, right? But that could be more work than it needs to be. Look at the smaller number here. Can I multiply that by anything so that it becomes 14? In other words, is 14 a multiple of 7? And it is. So in this case, we would only have to multiply 7 by 2. And if we multiply 7 by 2, then remember we multiply the 3 by 2 because we're using equivalence. And then what do we end up with? Well, now we have 6 over 14 plus 5 over 14. And now that we have the same size denominator, we just add together the number of pieces we have, 6 and 5. So we end up with 11 pieces of size 14, or 11 out of 14 to make a full tray. So look at the second one now. Do we have a common denominator? No. So can I multiply this by something to make it 20? I can. I can multiply it by 4. Got to multiply the top as well because I'm using equivalence. Remember, I am making a fraction that has the same value but a different appearance. So now I have 8 over 20, which is equivalent to 2 over 5, minus 7 over 20. And now since I have the same denominator, I just subtract my numerators, and I'm left with 1 over 20. So we need a common denominator, right? Now, when you have mixed fractions, a lot of people will say, okay, I'm just going to add this and get 6, and then I'm going to add my fractions. And yes, you can do that, but I just want you to be really careful because when you end up with negative fractions, things get a little bit more complicated. So let's form some good work habits. And forming good work habits is going to involve converting to improper fractions first. So convert to improper first. It's just a good habit to get into. So remember here we're going 3 times 4 to get 12 because we have 4 full trays of size 3. And then we're going to add 2. So we get 14 over 3. And then we're going to go 8 times 2 plus 5, so 16. So plus 21 over 8. Now, if you look at our last page, right, it was going to multiply 1 to get the other. Well, we can't do that here because we have 3 and 8. So the easiest way to get it is I'm just going to multiply 3 by 8, 14 by 8, and then 8 by 3, 21 by 3. That's going to guarantee me a common denominator because 8 times 3 is the same as 8 times 3. So my denominator now is 24, and now 14 times 8 is 112. So I have 112, and then 21 times 3 is 63. So now that I have a common denominator, I can add them up, and I get 175 over 24. Now, you might think, can I simplify that? And one, I do not need a mixed fraction. I'm happy with improper fractions. And how to determine whether or not you can simplify it is remember that 24 is the same as 3 times 8. And 8 is the same as 2 times 4, which is 2 times 2 times 2. So unless I can divide 175 by 3 or 2, I'm done. And 175 is not divisible by 2 because it's not even. And if I add those digits up, 1 plus 7 plus 5, watch my video on divisibility to remember that one, divisibility. 1 plus 7 is 8, plus 5 is 13, so I cannot divide by 3. So that means that that fraction is simplified. You do not need to convert it to a mixed fraction. So now, important here when you're converting the next question. So this is a negative fraction. which means I have a negative quantity of something. I'm going to have a negative quantity when it's improper. So don't worry about the negative in your conversion. It's still just 7 times 2, which is 14, plus 3, which is 17 over 7, and then minus 4 over 9. Now again, I can't multiply 7 by anything to get 9. Off the top of my head, I can't think about a multiple of 7 or 9 that is lower than their duality multiple, we'll call it, which means I'll just multiply 7 by 9, 17 by 9, 9 by 7, 4 by 7. That's going to give me my equivalent fractions. So my denominators will be 63 and 63. 4 times 7 is 28. And now just to make sure I don't screw that up, 17 times 9, 63, 153. And just to show you that is negative, right? Because it's negative and negative. So when we subtract a positive, it's the same as adding a negative, and we already have a negative, so we just need to continue down our negative spectrum. So the 153 becomes 181 over 63, but negative. And again, can we simplify that? Well, 63 is only divisible by 7 and 9, which means 7 and 3 and 3. So if 181 is divisible by 7, then we can simplify it. And if 181 is divisible by 3, then we can simplify it. Well, 181 is a sum to 10, so we can't divide by 3. So we just need to check to see, can I divide that by 7? 7 goes into 18 twice with 4 remainder. Not going to happen. So that, again, is simplified. If you're confused or unsure of what I just did with the simplification, again, watch the divisibility video on how do we know when something is divisible by, say, 2 or 3 or 5 or 7 or so on and so forth. Remember, all this stuff builds. So let's look at one that's just a little bit more challenging, and then we will call it a day. So we have multiple fractions here, which is totally fine. You can do this all at once, or you can do it piece by piece. Let's do this all at once. So my first thing I'm going to do is I'm going to convert that. So 2 times 2 is 4, plus 1 is 5. So I have 2 over 3 minus 4 over 9 plus 5 over 6 minus 5 over 2. Now, if I look at those three numbers, I can multiply 3 by 6 to get 18. So that'll work. I can multiply 9 by 2 to get 18. I can multiply 6 by 3 to get 18. And I can multiply 2 by 9. So there's my lowest common denominator. It's going to be 18. So I will just put in my equivalents and rewrite these. So now I have 12 over 18 minus 8 over 18 plus 15 over 18 minus 45 over 18. And what we'll do here is we'll do it bit by bit. So we'll do this first. 12 minus 8. So now I have 4 over 18 and then plus 15 over 18 and then minus 45 over 18. And now this part, 4 plus 15, so now I have 19 over 18 minus 45 over 18. Now, if you remember back to section 1.1 on just adding and subtracting numbers, if I am subtracting a number from another number, the difference is the same. So I can just as easily go 45 minus 19 and get 26, but know that since I'm taking away more numbers, my answer will be negative 26 over 18. Now in this case, I can divide both of those by 2. I can factor out a 2, so now I have negative 13 over 9, and I am done. So these just take a lot of practice. I might make them look easy. I've been doing this for a long time. So take your time, practice, practice, practice. There's a lot of practice in the workbooks, and there is a lot of practice on the additional practice section at varying levels of difficulty and challenge. So pick what's good for you, start there, and then build from there. The idea is growth. Thank you so much, and I will see you next time.